Okay, think we're in. All right. So today we are introducing polar coordinates. Okay, polar coordinates. So we're going to talk about how do you graph a polar coordinate. We're going to talk about what are different ways of representing polar coordinates, and then how do you convert from polar coordinates to what we're already familiar with, which are called rectangular coordinates, and how do you convert from rectangular coordinates back to polar coordinates. Okay, so when we walk out of here today, we should know that. If you think about it, until this date, what is today? 12/6/16. Whenever we try to plot a point or graph an equation, we always use this system that we call the rectangular coordinates, which has a horizontal component, x, and a vertical component, y, right? And using horizontals and verticals, we can identify a given point on a plane, correct? Okay? But who said that that is the way to do it? Okay, there are other ways to represent points in the plane, and that's what we're going to talk about today. This is called polar coordinates, and you might say to yourself, well, golly jeepers, Mr. Lothrop, sir, why would we ever care to want to learn this? And I can just tell you that when you graph polar equations, it is way cool. Like, it's ridiculously artistic. Like, you can create flowers and petals, and there's beautiful symmetry. And I'm not even like that artsy, and I get pumped up about it. Okay? So just to know, there's just another way to do this. For example, let's say I wanted to graph a point in the polar coordinates. First of all, the points, instead of x, y, they are r theta. Okay? R theta. R represents the radius. Theta represents the radian measure of the angle. Okay? We're used to x's and y's. We're going to be talking in r's and thetas. If I were the creator of this, I probably would have called it theta r, because you actually use theta before you do r, but I'm not, and it's r theta. Okay, so for example, if I wanted to plot the point 3 pi over 6 as a polar coordinate, okay, then I would just go to the pi over 6 reference angle, okay, which is on here in blue in the first quadrant, okay, and the radius is 3, so from there I would just count out 3 radii. Blam. There's the point. 3 pi over 6. Does that make sense? Yay? All right. And then if I said, okay, how about if you guys plotted the point 4 3 pi over 4. Okay? So on your graph that I handed you, plot the point 4 3 pi over 4. So if the first one made sense, then you know that you're first going to just start on the positive x-axis. You're going to go counterclockwise to 3 pi over 4, which just means you have a pi over 4 reference angle in the second quadrant, right? And you're going to go out 4 units. So this point in the second quadrant would be that point. Does that make sense, everybody? How many of you guys got that on your own? All right, giddy up. So now, here's the next thing that we got to do. There is more than one way. There are actually 4 different ways to plot the same point. Okay? For example, let's go back to 3 pi over 6. I could have said 3 and then gave the negative radian measure of that angle. What would the negative radian measure of that angle been? This one, 3 pi over 6. Renee? Yeah, negative 11 pi over 6. Everybody agree? That is 3. So if I just go in a negative direction, that puts me at pi over 6 away from negative 2 pi, which is in fact negative 11 pi over 6. Does that make sense? All right, now, there are two other ways that we can represent this same point, all right? And it is when the r value is negative, okay? So, for example, I would say that, again, I'm still trying to, another way of saying this exact same point, okay? If I went to a pi over 6 reference angle in the third quadrant, okay? A pi over 6 reference angle in the third quadrant, which is 7 pi over 6, isn't it? A pi over 6 reference angle in the third quadrant, okay? Now think about that. That puts me right here. Everybody agree? That puts me right there. That's the terminal side. So if I am at that terminal side and r says negative 3, well, that means I'm not going to go out 3 units on the terminal side that I'm at. I'm going to go out 3 units in the opposite direction. Okay? So I'm at 7 pi over 6. If it says negative 3, that puts me right back here at that same point. Because it basically says, take me to the terminal side, and if it's negative, I'm going to go in the opposite direction. Does that make sense? Okay, let's do, yeah. Right, right. That kind of makes sense. Because basically we're saying, go to the terminal side, whatever the terminal side is. In this case, it was 7 pi over 6. So I'm going to go to 7 pi over 6, which puts me here. You agree? Okay? But if it's if r is 4, well, then I would just go out 4 units on that, on that terminal side. But in this case, it's negative 3, which means on this terminal side, I'm going to go in the opposite direction. Right. Right. So what would be the other one? Negative 3 with a negative coterminal side with this in the third quadrant. This pi over 6 reference angle in the third quadrant. Pi over negative theta angle, pi over 6 reference angle, third quadrant. What would it be? Negative 5 pi over 6. So negative 5 pi over 6 would also represent that same point, because I would go in a negative direction, pi over 6 reference angle. I'm pi over 6 away from pi, right? So that puts me at a pi over 6 reference angle in the third quadrant. R is negative 3, so I go in the opposite direction, which again puts me right here. Okay? All right, here's what I want you guys to do. With this point, 3 pi over 4, see if you can come up with the other 3 ways to represent that. Okay? Try to do that on your own. What are the other 3 ways that we can represent 3 pi over 4? Okay, so the negative 4, negative pi over 4, so basically if this is the point that I'm talking about, then the terminal side that I'm curious about is the pi over 4 reference angle down here in the fourth quadrant, right? Because if it's negative pi over 4, that would be this terminal side. And then if the R value is -4, then I'm not going to be going out this terminal side. I'm going to be going in the opposite direction 4 units. Does that make sense? So this is the point, right? If this is the terminal side down here, this pi/4 reference angle in the 4th quadrant, okay, and if you went out, so if you went out 4, you'd be going out 4 units on that terminal side, right? If it's -4, you're going to go in the opposite direction. Okay? All right, so, all right, now you will notice at the top of this page, you'll want to get this down in your notes. At the top right-hand corner here, we have x equals r cosine theta, y equals r sine theta. Write that down. Okay? And then also write down the tangent of theta equals y over x, and then r squared equals x squared plus y squared. Write that down. Okay? All right, so last thing we got to talk about is just how do we convert from rectangular coordinates to polar coordinates, and how do we convert from polar coordinates to rectangular coordinates, okay? And we're going to use these 4 formulas to do that, okay? And before we do that, let's just kind of look at them, because really we're not learning anything new. Like, this is stuff that we already know. Like the first one up here, doesn't the cosine of theta equal x over r? Cosine of theta equals x over r, right? And if you just multiply both sides by r, you get x equals r cosine theta. Okay, that's where that comes from. So it's not like something that we don't already know. Okay, y equals r sine theta is derived in the same way. Like, why would we use these? Well, if we know r and we know theta, if we use this formula, I could find the x coordinate. So if it's in polar form, I can find x and y by using these 2 formulas. Okay? Over here, if I'm in, so with these 2, if I know x and y, that is if I know rectangular coordinates, I can find theta using this one. I could substitute in x and y, and I can find r using this one. And these are both formulas that we already know. Tangent of theta equals y over x. That's just Pythagorean theorem, right? X squared plus y squared equals r squared. So it's not like we're introducing something that you don't already know. We're just using it to convert from rectangular to polar and from polar to rectangular. So, so let's do one. Let's see. How about the ordered pair 4, 3 pi over 6. Okay? So we want to convert this. This is currently in r theta. It's a polar coordinate, and we want to convert it so that it is a rectangular coordinate. Okay? So I would suggest that you just, if you can, Alejandro, that you just Widmopoy these first. Okay? Like, isn't this, can't we just reduce that a little bit and say, well, that's just this, right? Now think about this. If I Widmopoy this, because a lot of these, if you Widmopoy them, you don't even need formulas to figure them out, okay? I would go to pi over 2, and then at the terminal side, pi over 2, the radius is 4. Isn't that the point 4 pi over 2? Are you with me? So you'd go to the angle pi over 2. There's the terminal side, okay? And then you're going to go up 4 units. What is that point as a rectangular coordinate? What is it? What ordered pair is it? It's 0, 4, isn't it? Okay? So when we use these formulas, sometimes when you Widmopoy, you know what the answer is. You don't even need a formula to do it. Okay? So now let's just show that, in fact, that's what it is. On your formula sheet, x equals r cosine theta, and y equals r sine theta, right? So r was 4, and we're finding the cosine of theta, and theta is pi over 2. R sine pi over 2. Okay, what is the cosine of pi over 2? On a unit circle, what is the x-coordinate at pi over 2? 0. So this is just 4 times 0. What is the sine of pi over 2? What is the y-coordinate on a unit circle at pi over 2? 1. So we get 0, 4, which we already knew was the answer. Does that make sense? So if you Widmopoy it, oftentimes you're just going to know the answer. You won't even need to use a formula to find it. But you can always use the formula to find it and you'll get the same thing. That makes sense? So if it's an easy one, I would just Widmopoy it and give the answer. If it's ugly, like it's something that's not obvious, then you have a formula that you can use to find the answer. Okay, let's try another one. 2 pi over 6. Okay? All right. 2 pi over 6. I know I'm at a pi over 6 or 30-degree reference angle, and I know the radius is 2. Okay? Go ahead and try this one on your own. Okay? So use the formula. Use the formula to try to bust this out. Look up here only if you have to. See if you can kind of do it on your own. Okay, we're back. All right, let's do it the other way, okay? Let's do it the other way. So let's say I have this point, okay? This is a rectangular coordinate. So when do you guys think you first plotted a point? What grade? Yeah, so way back in the day, like 4th grade, 3rd grade, Renee thinks. Alejandra? Oh, Alejandra, you're not listening to anything we're saying, are you? Okay. So this is the point, rectangular coordinate. I want to know what is its polar coordinate, okay? Guess what I'm going to do first, Alejandra? Could you please put your phone away? Thank you. What do I do first? Widmopoy. So I'll Widmopoy. So if I Widmopoy, boom, 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 there's the point, 2, 2. What would be its polar form, okay? Well, if I Widmopoyed this, if I truly Widmopoyed this, couldn't I do this and say, ooh, this is a right triangle, and the legs are 2 and 2. What kind must that be? Ooh, it's a 45, 45, 90. So isn't theta just pi over 4 because it's a 45, 45, 90? And then, of course, if you had any kind of a geometry teacher whatsoever, then you know in a 45, 45, 90, how do you get from the leg to the hypotenuse? Lauren, did you have a good geometry teacher? Yes, it is, Lauren. It is. It is radical 2 times the leg. Oh, that pumps me up, Lauren. So this is 2 radical 2. If you remembered that to get from the leg to the hypotenuse, you multiply radical 2. Okay? So that means that r is 2 radical 2, and theta was pi over 4. Right? But let's say that you don't remember any of this. Okay? Well, then I was telling you, you can utilize these formulas because we have the rectangular coordinates, x and y, so we can find r and theta by using these. So Liz, like you were saying, if it's not something that's nice, then you know you can just use this. So let's find theta first. We know that the tangent of theta is y over x, which would just be in our ordered pair 2 over 2, right? So the tangent, yes, the tangent of theta is 1. And if you inverse tangent on your calculator, okay, you will get 45 degrees. I would keep it in degrees when I was doing this. You'd get 45 degrees, which we know is pi over 4. If you keep it in radians, you're going to get pi over 4 as a nasty decimal, and you won't recognize it. So I would use degrees on my calculator to get that. Okay? And then if you don't know r, which is 2 radical 2, okay, then to find r, I know that r squared equals x squared plus y Schneikes squared. So r squared would equal 4 plus 4, or 8. So r would be a very radical 8, which is 2 radical 2. Alejandro. A reference angle? Right. Then, yeah, either or. You can write it as a radian too, but that's what Liz was saying earlier. Then you just have a decimal, a nasty decimal answer. Okay? All right, how much time do we have? All right, I think we're going to stop right there. I wanted to do one more, but shenanigans. Okay, so the assignment, which is up here on the whiteboard, page 711, 5, 7, 11, 13, 17, 19, 23, 25, 29, 31. Good day. And the bell rang. Lions and Tigers and Bears.